Hello everyone, welcome to our presentation on modeling design of finance AI agent. In this presentation, you'll get our design from four perspectives. To begin with, let's talk about the requirements. How does the requirement model build in our product? The requirements are based on the differences in roles, tasks, and operations. After analysis, the team has summarized the different requirements for the four distinct roles, including investors, brokers, regulators, and the technical team. Investors are the most important users of the platform. Their aims are earning money. As a result, we provide AI-based functions like trading bot and semi-auto investment to satisfy their needs. Brokers serves as intermediaries between investors and the financial markets. They want orders, so we provide order information of investors to them. Regulators are obliged to ensure that the platform operates within the legal and ethical frameworks of the financial industry. Under this circumstance, AI-based fraud detection meets their goals conveniently. As for us, the technical team, we are responsible for the maintenance, development, and security of the platform. Thus, issues like permission management and LLM fine-tune are all our jobs.
After discussing the requirements for our project, let's move on to the proposed design and choices we made. For the dominant model of computation, we choose the procedural model of computation, where each function executes sequentially after the previous one. This approach reduces coupling, simplifies debugging, and makes complex logic more understandable. For instance, our trading bot relies on a sequence of tasks, collecting user information, processing deposits, and generating trading parameters. While complex, the procedural model makes it easier to implement and understand. In the section of control in architecture, we opt for separate control instead of centralized control. By isolating the control module from functional modules, we achieve lower coupling and improve program efficiency. This also makes it easier to locate issues during troubleshooting. The last design issue is the architectural design pattern. Our design follows the four-layer architecture. In the data access layer, we interact with databases for user and market information. The business logic layer implements core logic by classifying entities. The service layer provides features to meet stakeholders' requirements. Finally, the presentation layer displays necessary information, offering an intuitive user interface.
The third part is the overview of models. The actual diagram shows basic idea of the system. The system collects real-time market data and user preferences as input for financial LM. The general LM then generates and outputs detailed reports based on the information from finance LM. For feature diagram, it shows the different functions and features which will appear in use case after. For the use case overview diagram, it shows interactions between investors, brokers, the technical team, and regulators with LM. Users register to log in and choose investment options based on risk preferences and market data. Trading bots handle transactions and log data for compliance. The system also detects and alert on fraud activities. Meanwhile, the technical team manage permission, update the system, and ensure its security. The fourth part in use case is use case specification. In this part, each of us selects three main pictures and make explanation for them, including header collections of scenarios and event flow. The class diagram illustrates how the financial system operates. User info surveys manage user data for investment advice and automated trading. Trading bot executes trade using data from data surveys and user info surveys. Logging transactions via order and transaction surveys. The system also monitors for fraud and issues alerts. Generates investment advice and portfolio management classes. Utilize user and market data, interacting with general LM to deliver personal investment advice. The object diagram is an instance of a class diagram. The detailed information refers to the document.
Let's start with an overview of the activity, interaction, and the state diagrams. Each team member has selected a classic scenario from their completed use case specifications. In activity diagram, for instance, we can see the trading boat steps, where an investor sets up the boat and checks financial statements before starting it. Interaction diagrams show communication between parts. Here, we look at the Manage Portfolio Sequence diagram, shows how the investor to review and update their portfolio details. State diagram display the states and changes within a system. Here's our examples. Now let's look at the package diagram. The system is divided into layers: the data access layer, which interacts with the databases for data accuracy; the service layer, which connects directly with user when combined business logic and provides APIs; the business logic layer, which handles operation and relationships; and then the presentation layer. Finally, let's discuss the deployment diagram. Here, the browser client communicates with the Django web server through HTTP. The Django server, hosted on a Windows server with Apache, connects with LangChain server for managing AI models. Additionally, it connects to a data server managed by MyCircle through Django ORM, and interacts with an external broker APIs.
Lastly is our basis for change assessment and acceptance determination. For change assessment, we focus on 4 main points. Using these principles, we made several adjustments. For example, the original analyzed anomalous behavior use case running real-time, causing a heavy system load. We changed it to only run when the regulator sends a request, which improved performance while maintaining system structure. We also added register and login features. During our midterm review, we realized users couldn't even log in. Adding these features made the system more stable. Additionally, we include collect market data and market chart view to help users better grasp market changes, which improves scalability and user experience. All of the changes met our acceptance criteria by enhancing functionality and maintaining compatibility. That's all. Thank you.